And we can add a smooth to Plotly, but it's a little bit more difficult because we have to manually compute each of these linear regression models, extract that formula for each of those lines for each group, and then add a line on as a separate layer each time. So we'll first kind of break that up into a couple of steps. So in the first code cell below, we're going to fit separate linear models for each of the different species. So there is a function in base R called LM, and that is used to construct a linear model. And so if you're curious about that function, you can do $LM and open up the help documentation in the help window over here. Let me run this code. Okay, so you can see what this LM function does. It fits linear models and it has all of the documentation over here. What we want to get in the end is we want to figure out what the model is that's going to fit for a given body mass, what is going to be the predicted bill length, right? So our plot has body mass on the x-axis. This is the predictor variable. Bill length is the y, is the output, is the response variable. So when we construct our model, we first enter the response variable is bill length. So this is like the y value. I put tilde, and I'm going to say I want to predict the bill length based on two predictors, body mass and species. So I'm going to get a different prediction for different species. So that's what's going on here. So based on the species and the body mass, I'm going to get a prediction for the bill length. And so for different species, those predictions are going to work differently. The data that we are going to use to fit this model is in the penguins data frame. And there are some missing values in the penguins data frame. The ggplot function knows to ignore them, although we get a warning message. It doesn't cause the code to crash. The LM function, I do want to specify what to do with the NA values, and I am going to tell R to ignore those values. So delete the missing values and then construct your little linear model with all of the remaining data. So all of that output is going to be stored in something that I call L model. And L model, or L mod, excuse me, has a whole bunch of information. So let me run this code cell. And we won't see any output here because we haven't asked any output to be printed to the screen. But let me input a code cell. And let's take a look at like what is in the LMOD. So I'm going to do summary LMOD, and you can see that we get a lot of information from this, and probably a lot of this doesn't make sense if you have not taken a course in regression. That's a good plug. You should take Math 4387 at CU Denver. It's a great class. But you can see there's a whole bunch of information that's being stored in LMOD. And what we're going to be interested in is the fitted values. So the fitted values are the predicted values from this model, and that's what we're going to want to fit. So we're going to extract those fitted values, and we're going to store them into a data frame. We're going to add on a variable to the penguins data frame. So we're going to add a column to the penguins data frame called fitted, and that's what this last column did. Let's take a look at that penguins data frame. Let me insert a new code here. And let's take a look at what the Penguins data frame looks like now. And you can see we have a column that was added to the Penguins data frame called fitted. It ignored the missing values, or at least the observations that had a missing bill length or body mass. So this had missing values, so that's why it just ignored it when it set up the model. So this is telling me what the predicted bill length is, and this is telling me what the actual bill length is. So these are telling me I fit a model, and then this was the actual body mass of one of the penguins. This was their actual bill length. And what this column is telling me is this is what the predicted bill length is by my linear model. So that fitted column has a bunch of points that sit on this line, right? And I'm going to have three different models that are going to have three different predictions. So now I've got the actual data points stored in Penguins, and now I have the predicted values stored in the Penguins data frame in a column that we called fitted. And from this information, we can now construct our interactive scatter plot with linear model added to it. So we're going into the Penguins data frame again. We're pulling off X to be body mass. We're going to map the bill length is our response variable. That is getting mapped to the y-axis. We are going to set up a scatter plot, so that's why I've got type scatter. We're going to map each observed value to a point, and we're not going to connect them with lines or anything. So that's what mode markers is telling us. And then we're going to color each point differently based on the species, and we're going to give it a different symbol based on the species. So this was all the original Plotly code that we used to generate the scatter plot in the previous video that was over here that did not have any linear models added for the three different species. So I'm going to add those lines as an extra layer. So over here, I pipe that in. So I'm going to take this graphic that I created, this interactive scatter plot, and I'm going to tell it now we're going to add some lines to it. And we're going to get those lines by using the Penguins data frame. The X values are going to come from the body mass. The Y values are going to come from the predicted values that we stored in the new fitted column. So we just added that column to Penguins. We're going to give it a different color based on the species. And then we're going to set this inherent function equal to false. And this means that we are not going to inherit any of the attribute applications in the Plotly function. We're just going to use everything that was passed by default instead. And here we've got our three clouds of points for each of the three species with the fitted line mapped through as well. So that's our interactive scatter plot with smooths. The theme that you might be picking up on is that it's a lot easier to just create things in ggplot first and then pass them through ggplotly. But some Plotly graphs are easier to create than others. The scatter plot was not too bad to create, but when we wanted to add lines, regression lines to that plot, we needed to fit the regression lines separately, store that information back into the Penguins data frame, and then plot that newly added information as lines added separately as an additional layer to that. Okay, thanks everyone.